You may remember, or you may have heard, Einstein's relativity, where the faster you move, the slower time ticks for you.
Right.
You don't know anything's happening. Your clock still ticks as far, you still got your heartbeat, all of this. Okay, so this is not a physiological thing. It is an actual property of the fabric of space and time under those conditions.
Wow.
Okay?
That is fascinating.
It is. It's completely fascinating.
But my time stays the same.
To you.
To me. Right.
To you. So not only does speed do this, also the strength of a gravitational field will have the same effect on you. The GPS satellites orbit higher than that is far enough away from Earth's source of gravity for them to have a measurably different space-time condition, so that their clocks tick faster than our clocks on Earth's surface.
Wow.
But we get precise timings from geosynchronous satellites. So how does this work? We pre-correct the time signal from the GPS satellites to compensate for Einstein's general theory of relativity, so that by the time the time reaches us, well, it's been properly corrected and it matters to us and our space-time continuum, not the one that's at middle Earth orbit.
Oh my goodness.
So GPS couldn't work as accurately as it does.
However, wait a minute.
What?
I'm sorry, just for me, you would have to have a standard in order to pre-correct something.
You know the rate at which its time is speeding up, because you can calculate what the gravitational field is up there.
There you go. There you go. Okay.
And once you calculate that, then you do, and you say, "Oh my gosh, the formula works. Einstein was right."
Right.
All right. This is not just something on a high theory,
By the way,
hypothesized that may or may not be true. It is true.
I just want to be there when that phrase is uttered. Oh my God, Einstein was right.
Yeah, these aren't just cult heroes that we wish they were right.
Right.
These are real. This is real. Okay, this is the real universe we're talking about. Okay, so now watch. Let's keep going faster and faster. Let's go half the speed of light, three-quarters the speed, 90% the speed of light, 99% the speed of light. Time is ticking slower and slower and slower. For you, you will watch the whole future history of the universe unfold in front of your eyes as fractions of a second go by for you. As you go 99, there's a formula for this, of course, but
because you're the observer of that.
that.
For you, your time has slowed to the point where as you observe the things that are not moving at the speed of light, you see them
speeding.
Basically,
Correct.
you see
Speeding
them
up.
unfold.
Correct.
Boom. God.
Correct.
That is insane.
Okay. So now watch.
Oh my God, wait.
No, watch. Okay.
Wow.
So, I didn't even get to the part where I lose sleep.
Okay.
Okay? That's what happens. By the way, some particles, let's take, for example, the proton, muon. I forgot which of these, but it doesn't matter for my example. Decays in like 6 minutes, okay? Okay. What happens if you take that particle and speed it up in a particle accelerator? So you take a community of these particles, speed them up, calculate, wait a minute, the internal wristwatch on these clocks says they should live longer. And sure enough, their decay time takes longer.
Wow. That's, oh my God.
Yes, yes.
So oh, wow.
Yes.
And that becomes living proof of what Einstein said.
Yes, because we can't go half the speed of light.
Right.
But you can accelerate a particle to do that.
Yes.
And it has an internal built-in clock that decays after a certain amount of time, and there they are taking longer to decay in the exact amount that Einstein predicts.
That is genius.
So we don't make this stuff up, okay?
Yeah.
Yes, it is genius. It's like triple genius. All right. Now, let's take this to an extreme level.
Right.
Let's go so fast that we're going the speed of light itself.
Right.
Well, we can't do that because we're made of material substance, but there are things that travel at the speed of light. And what is that?
Those would be photons.
Yes. Thank you. What travels at the speed of light? Light does.
Yeah.
Okay.
I was about to say light.
So, if photons had a clock, the clock would never tick.
Nice.
Which means when I go to a mountaintop, as I did in graduate school, to observe the center of the Milky Way galaxy for stars that emitted their light 30,000 years ago, traveling through the gaps of interstellar space, and they move through space, come through Earth's atmosphere, they come down into the telescope, they reflect, go back to my detector, and land on my CCD chip. That photon, when it was born, at the star that emitted it, was detected at my telescope in the same instant.
Wow.
According to the photon itself. The photon has no knowledge of that trip
Right.
because time did not exist for it.
That's great.
And I'm saddened that many of these photons like hit people tanning on the beach, you know, and
they're
imagine
very
traveling
sad.
30,000 years and land on someone's buttocks,
Yep.
but they have no internal time clock. Just the idea that light can move across the universe and have no, and not age. This is a fascinating fact to me.
Wow.
So, yeah.
That is more than fascinating. That is,
Yeah.
I mean, that's mind-boggling.
Yeah. So that is light, the age of light. It's like
Yeah.
it doesn't age at all.
I am convinced that all of you guys secretly microdose and smoke weed. That's
another episode. That's what I'm saying.
Another
No.
episode.
All right, Chuck, we'll call it a quiz there.
All right.
All right, mysteries of light and time. Neil deGrasse Tyson here. Keep looking out.